Angelo, this is 2c here, and we've got a vector like this, 2, 1. Okay, so there it is. Now, there are two ways to approach this problem. The problem being, what is the expectation value of SZ? Right? Now, you approach this with the matrix way, but you used two column vectors. Let me see where I put your stuff. That's not your stuff. Okay, well. Yeah, there it is. So you used two column vectors. You see, this is a column vector. This is a column vector. When you have the look at this guy right here. So this is the ket. Yes, the ket is the column vector, but this is the bra. The bra is the row vector. So this needs to be a row vector. Let me work it out so you can see what I'm talking about. So I'm going to do this guy. I'm going to do this guy right here, just like you did. I'm going to call this C because it's part C. I'm going to do this guy just like you did, right? Except I'm going to make this the bra, so the bra is 2, 1, like that. Okay, so it goes 1 root 5, 2, 1, and then the operator. I'm going to write the operator now. The operator being h bar over 2, 1, negative 1, 0, 0. Let me check my notes, see if that's right. 1, negative 1, 0, 0. Yeah, okay. So that is the operator. And now this operator operates on the thing to its right, which in this case is this ket. Okay. So let me get rid of the constants. So this is going to be I'm going to just copy this down. I'm leaving the bra completely alone. Why? Because the operator operates to the right. It doesn't operate to the left, usually. I'm just doing this stuff first because the operator operates to the right. All right, now I'll move this constant over there, and now do this multiplication here. I'm going to get a column vector. It's going to be 1 times 2 is 2, and then this is negative 1 times 1. So this is negative 1. Okay, so now I'm going to do this multiplication. Now this is a row vector times a column vector. That's just a dot product. So I'm going to move these constants out of the way. So that's h bar over 2. Now root 5 times root 5 is just 5. So 2 times 5. And now I'm going to do this dot product. So 2 times 2 is 4. You found the same thing. 1 times 1 is negative 1. So this is 4 minus 1. And so now I got 3/10 h bar. That is what I get for the expectation value of SZ. Let me show you that this can be done this can be done without the matrices. All right. So if we just remember that SZ has no, not the vector, but the operator SZ. So let me just move this over here. So now the other way to do this, which gets you the same answer, is that SZ is an operator, and this operator has two eigenvectors. One of them is for the spin up, and one of them is for the spin down, and that's all it has. Now the spin up eigenvector is this, and the spin down eigenvector is this. All right? And then when you operate this operator on the spin up eigenvector, you get an eigenvalue. And the eigenvalue is SZ on the spin up eigenvector. Okay, some people call this the some people call this spin up some people call the spin up eigenvector as they call it SZ equals positive 1/2. They call it that. All right, it's the same thing. And some people call the spin down eigenvector as they call it SZ equals -1/2, all right? But anyways, when you do that operation, what you get is h bar over 2 as the eigenvalue and minus h bar over 2 as the eigenvalue for the spin down, and then you get the same ket, of course, because it's an eigenvector for that operator. That's how they work, yeah? Okay, cool. So how did I know that you get h bar over 2? Well, I just did it with the matrix representation of SZ. You know, it's this guy. I just computed this guy on this guy, and I got h bar over 2. And I computed this guy on this guy, and I got negative h bar over 2. So that's how you do that. Okay, so anyways, now that you know that the eigenvectors and the eigenvalues for this operator, what you do is you express your psi. So this I'm still doing part C. This is the second method. This is another method of doing part C. So you express the psi as a linear combination. Now you were kind of doing this, but I didn't follow your work completely there. So you express this as a linear combination of these eigenvectors. So to get these eigenvectors, you're going to have to do you're going to have this constant, and then how do you get the 2, 1? Well, the 2 is 2 times this, right? So it's 2 times this. And then the 1 is just 1 times this. All right? And so we end up with psi of part C being just 1 over root 5 times the combination of 2 of the spin up eigenvector plus 1 of the spin down, spin -1/2 eigenvector. Okay? And now, the reason why people like to do it this way, solve this problem, a problem like this way, is because we're going to collapse wave functions now, and things are going to cancel out to 0. Anytime, so we're going to multiply stuff out using algebra, and then anytime something ends up like this is just 1. And anytime something ends up with different bra and ket, that's just 0, right? So that's what we're going to do now. That's what I'm going to do here. Now, if you don't need to see this, just stop the video. You know, you're paying. You're the customer. You're right. So, what am I doing? Oh yes, I'm doing this guy, C. All right. Okay. So now I'm going to rewrite these guys as their combinations, linear combinations of eigenvectors for SZ. So this is 2 of the spin up. Oh, but it's not a ket, remember, so we're on the bra side of this expression. So it's 2 times the bra of the spin up guy, right there, 2 times the bra, and 1 times the ket. 1 times the bra of the other thing. Okay, so have I got that right? I'm just copying it down. This is this. That's what it is, except with bras instead of kets. And then I do SZ on the following, on 1 over root 5 times the quantity 2 of the spin up plus 1 of the spin down. All right? Okay, good. Now I'm going to leave this alone again because operators still operate to the right. So I'm going to just copy this down over here, copy this bra stuff down, copy the bras down. So if I write the bras really fast, is it a sports bra? Sorry. So 1 over root 5, and then SZ operating on, oh, there's a 2 there. Okay, so hang on. Alright. Okay, so 2 over root 5. Now SZ operating on the ket, on the spin up ket, plus, now this is just a 1, so this 1 over root 5 distributes over, so 1 over root 5 SZ operating on the spin down ket. Alright, so now I'm going to simplify this. Alright, I'm just going to copy things down, but I'm going to to perform this operation. Now, because the spin up ket and the spin down ket are eigenvectors or eigenkets of the SZ operator, the answer to this operation is just going to be the eigenvalue times the same ket. It's that simple, right? So I'm going to copy this down real fast. I'm going to copy the sports bra down real fast. Sports bra. Okay, and now 2 root 5 times, now what's the eigenvalue of SZ operating on the spin 1/2? The eigenvalue is h bar over 2, and the other one is negative h bar over 2. All right, so this is just going to be h bar over 2 times the spin 1/2 ket plus 1 over root 5 minus h bar over 2 times the spin down ket. Okay, now look at this. If you're still watching, Angelo, then check this out. This is the reason why some people like it to do it this way. I'm going to use FOIL here. I'm going to use FOIL because I'm going to multiply all this stuff by all this stuff, right? Okay, so this is going to be 1 over root 5 times the FOIL. So first, okay, so that's, I have a ket times a bra, and they're the same. Okay, so that's going to be 2 times 2 root 5. That's going to be 4 over root 5. 4 over root 5, right? And that is the bra times the ket, right? Now remember, that's just 1, right? Let's take first now. Outside, this guy and this guy. Oh, but look, this is a spin negative 1/2 ket, but a spin positive 1/2 bra. So this is going to be plus whatever it is times this guy, this up bra and down ket, but that's just 0. Okay, so we don't have to even compute that. And the inside is the same way. I've got a down bra, and an up ket. That's also 0. So we don't have to even do that. All we got to do is this stuff now. This is the spin negative 1/2 bra and the spin negative 1/2 ket. So I do have to compute the eigenvalue there. So that's going to be 1 times negative h bar over 2 root 5. So negative h bar over 2 root 5 times the this guy. Now this is just 1. So we get 1 over root 5 times 4 over root 5 times 1 minus h bar over 2 root 5 times 1. Okay. I think I'm missing an h bar here somewhere. Am I? Okay, this shouldn't be 4. This shouldn't be 4. Sorry, this shouldn't be 4. This is 4 divided by 2, which is 2, times h bar. So this is 2h bar, not 4. Sorry about that. My bad. So this is not 4. This is 2h bar. Okay? So now I have 1 over root 5 times actually I'm tired of the radicals, so I'm going to distribute right now. So this is going to be 2h bar over 5 minus h bar over 5. Oh, no. There's a 2 here. There's 2. So 2 times 5. Okay, good. So this is 2h bar. Okay, so here. I'm going to multiply this by 2 and this by 2. So 4h bar over 10 minus h bar over 10. So that's 3h bar over 10. Okay, that's the same expectation value as I just found before this using the matrix method. Right? Where the heck? Yeah, right there. And that's the same thing. So you can do it either way. In this particular problem, the matrix method is kind of shorter. But in some other problem, they might throw at you something where it's much easier to do it with the bra ket way.